In these slides, we want to understand what happens to the potential difference between the conducting plates before and after you insert the dielectric material. So this is the situation before you insert the dielectric material. You have electric field E node, and we know that when you have a uniform electric field, the potential difference between the two plates is simply the electric field times the distance. Okay, when you insert the dielectric material, we've shown many times, many videos in the previous videos, that the total electric field inside the dielectric material is reduced by a factor, and it becomes less, and it has a value now E instead of E node. So the potential difference then now between the two plates will be this new electric field times the distance. Now, what is the electric field? How much is it reduced by? We showed before that there are two ways to say that the electric field has been decreased. One way is the superposition principle, is the total electric field, which is the electric field due to the conductors minus the electric field due to the induced charges. Or we can say that the electric field is reduced by a factor K, and this factor K is something easy that can be obtained experimentally. So let's use this second approach. So the potential difference after inserting the dielectric material, it's the reduced electric field times the distance. Now, what's this reduced electric field equal to? It's the original electric field divided by a factor K. So E is E node over K, and you have now this situation. Now, what is E node times the distance? That's just the potential difference initially, before you inserted the dielectric material. We found now a relationship between delta V after inserting the dielectric material and delta V node before inserting the dielectric material. It turns out that the potential difference is decreased by a factor of K. So this is, for instance, an experiment, a simple experiment you can do in the lab. You can take capacitor plates, you put charge Q node and minus Q node on them. The capacitor will have a capacitance C node. Get a voltmeter and connect it across the plates. You'll read a measurement delta V node. Remember, a voltmeter, an ideal voltmeter, never takes any charge from the capacitor plates. So even though you have a connection here to the plate, the charge on the plate will never change. Then, when you insert the dielectric material inside between the two plates, we showed that the potential difference will be reduced by a factor of K. So the reading here becomes less than it was over here. And this is a way to determine actually this value of K. So you can measure the value of K very easily in an experiment in the lab. And now in this case, we said that the capacitance of this capacitor will be larger than it was before. It'll have a value C. And now we want to try and figure out what's the relationship between the capacitance now, the new capacitance, and the old capacitance before inserting the material.